Welcome to my YouTube channel. This is Dr.Sengolrajan, Associate Professor in the Department of Tribly, Punganadu College of Engineering Technology. I am going to handle the topic integrated circuits, that is I2C in embedded systems. Let me see what is integrated circuits. Integrated circuits is nothing but a I2C, that is inter-integrated circuits. As we are going to connect the number of device circuits, each one for a flash memory, for example, one for a flash memory, one for a touch screen, measuring temperatures, and for measuring pressures in a number of processes in a plant means that we may require and more than one integrated circuits. So how we can be able to use two integrated circuits, that is I2C integrated circuits, for connecting the number of device circuits. So these ICs, what we can do means these ICs can be mutually networked together to a common synchronous serial bus. Then that's why this I2C bus is a popular for the circuits. It was being developed by Philips Semiconductors. There are three I2C bus standards. One is industrial 100 kilobytes per second inter-integrated circuits, 100 kilobytes SM I2C bus. Another one is 400 kilobytes per second I2C. There are three integrated circuit bus standards. Each integrated circuit, that is I2C bus, has two lines which carries the signals, that is one signal will carry the line for clock and the another one is for bidirectional data. So out of two integrated circuits, one line will carry the signal for the clock and the another one will carry the bidirectional data. It has specific fields. Each field will have a number of bits as well as sequence and the time intervals between them. Let me see the above diagram, that is illustrating how signals is transferring during the transfer of byte when we are using the I2C bus to a synchronous serial link. Here, if you take one integrated circuit which is being connected together to a synchronous serial bus, one signal will carry the synchronous data address. One will carry the synchronous data address. Another one will carry the clock signal. Then again, here the two signals, one will be carrying the data, another one will be carrying the clock signal that is being connected to another integrated circuits. You see the bottom, again two signals, one will carry the clock signal, another one will carry the data signal that is connected to another integrated circuits. So likewise, if you take any integrated circuits which has two synchronous line, one line will carry the synchronous data address, that is a bidirectional one. Another line will carry the clock signal. Let me take the timing diagram and explain for a better understanding. The timing diagram, that is time, is noted along the x-axis and the state along the y-axis. Here, an 8-bit data is taken. 8-bit data is taken here. That is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Each 8-bit data is separated by an interval and another 8-bit data will be continued. So one 8-bit data is called a frame. Is called a frame. For transferring one bit of data, it take a time period of T, capital T. So for transferring an 8-bit data, the total time period is 80. 80. So this is the one frame and one 8-bit data, which takes the total time period of 80 and separated by a time interval, and another 8-bit data is followed, or that the time period is another 80. This is nothing but the format of serial data address bit in the I2C bus. If you take the first box that is indexed with the dot, that is the first box, that is nothing but the first bit data. The first bit is called as a start bit. The first bit is called as a start bit. And second, third, fourth, fifth, sixth, seventh, and the eighth is nothing but an start address bit. Start address bit. Then again, the next bit is nothing but a which has the same index, that is called read or write indicating bit. This index is meant for read or write indicating bit, and this index bit is meant for acknowledgement bit. And next, this bit is meant for data bits, and this box is nothing but the empty box. No acknowledgement bit. NACK, no acknowledgement bit. The last bit is nothing but a stop bit. So this is the index of the serial data address bit format. That is, you can call it as SDA frame format. Then, if you are going to transfer your data, a master is required, and to receive the data or to do the process, the slave is being imported. So here, the master is nothing but a source device which can be able to transmit the clock pulses for synchronization at the destination. The master has a processing element which functions as a bus controller or maybe a microcontroller with I2C bus interface unit. Each I2C device has its own address. Using that particular address, the data transfer will take place. A master, in this manner, the master can be able to transfer 127 other slaves, 127 other slaves at an instance. So simultaneously, it can be able to transfer 127 slaves at an instance. Each slave can also optionally have I2C bus controller or a processing element. Any number of masters can be connected onto the bus. Okay, so a master is one which initiates a data transfer on a serial data line. Hence, master is nothing but a one which initiates a data transfer on a SDA line, that is serial data line, and which transmits the SCL serial clock pulses. So a master can be defined as a one which initiates data transfer on a serial data line, that is SDA line, and which transmits a SCL serial clock pulses. Then we can be able to see the sequences and fields in the data frames, from a master. Below the above diagram, we have been seen the field diagram, that is a data format. In that, the first field of the first bit is meant for start bit, which is similar to UART. That is, UART is nothing but a universal asynchronous receiver transmitter. And the second field of seventh bit is meant for address field, which is been defining the slave address that indicating where the data has to be sent, that is using master SDA as well as serial data address line as well as serial synchronous clock signal. In the third field of first control bit, is nothing but a control field one, which is defining whether read or write cycle is in progress. Whether read or write cycle is in progress. And the fourth field of one control bit that is called as a control field 2, which is defining whether the present data is an acknowledgement from slave. And the fifth field of 8-bit data is called as data field, that is for I square device data byte. And the sixth field of 1 bit is nothing but a NACK, that is called a negative acknowledgement field, in which the data frame, if it is active, acknowledgement will be done. A transfer is not needed from this level, else acknowledgement is expected from this level. Then seventh field of first bit is nothing but a stop bit. The 7 bits, that is the 8 bits sequence is similar to your universal asynchronous receiver transmitter. Coming to the, though in I2C, the master is able to transfer 127 slave devices, though there is advantages, but there are also some disadvantages that take into consideration is the time taken by the algorithm executing at a master hardware. Okay, master hardware, the time taken is more. The algorithm analyzes the bits through I2C in case the slave hardware does not provide for the hardware that supports it. Some ICs support the protocol and some do not. So the time taken for the algorithm executing at the master hardware is time is more. Sometimes the I2C bus protocol we may support or may not support. That is one difficulty. And the another difficulty is open collector drivers at the master, open driver collectors at the master. So yeah, 2.2 kilo ohm of each line is being required. I2C is a serial bus for interconnecting the ICs. It has start and stop bits as in the UART, and it has 7 fields, that is start, 7-bit address for defining read or write byte, for defining acknowledging data byte, then negative acknowledgement at the end. So that is open collector trace at the master. That is one disadvantage. Another one is the time taken for the master hardware is time is being more. These are the two disadvantages that come across in the I2C bus. Thank you. We have been discussed the I2C inter-integrated circuits in detail.